I have arriven. Oh, I need to put the card in the camera. Is there enough room on the camera? 2 hours and 31 minutes. That's not a lot of room on the camera. Just to be safe, let's clear out another one. Yeah. It sucks when the card runs out of the camera because it also kind of corrupts the recording. And now with the 2-hour long show, just all recording in one fell swoop. Okay, I got 10 hours now. Okay, that's recording. That's recording. Here you go, chat. 10-hour show. Yeah, exactly. It's coming. Jonathan, you want me to do this in French? You guys don't have Family Day in Quebec? Je ne parle pas français très bien. Je m'excuse. Je parle anglais. 10 hours, I guess that's how it works. Is that what we do? We just play like camera roulette. I just pick cards at random, put them into my card, and then I just record until the camera runs out, and then that's that. That's not a terrible idea. That'd be fun. We'll do that for a thon. Okay. Yeah, well, I mean, we all learned a little bit of French in elementary school and high school. I think I took French to grade 10, but yeah, and both my kids went through French immersion. So one had enough by grade 8, but the other one went all the way through to grade 12. So tabernacle. Okay. All right. So YouTube is telling me that I should initiate automated mid-roll ads on this live stream. And if I did, then I would get an increased 20% uplift in my in-stream ad revenue per hour, which is currently 0. What do you think? Do you want me to do that? Do you want me to turn on midstream ads and see a 20% uplift? Don't. No. We don't do ads on this channel unless YouTube forces us. And then if they do, then we put in the bare minimum that is required for them to not put in more ads. 20% of 0 is 0. There you go. No. All right. So here's the deal. If you want me to put no ads in this live stream, then you have to click the like button. That's the deal. Do you take my offer? Okay. Let's drown in French immersion. All right, let's get started. So for those of you who are wondering what it is that you have stumbled into, you are about to watch my Monday live question show where you ask questions into the YouTube comments and I answer the questions. And I have no idea what it is that you are going to ask me. I am completely and totally unprepared, unresearched. And yet, somehow, we will pull this together as a group. So go ahead, put any questions that you have into the YouTube chat, the live chat. We've got some collection of moderators here. I see Zapfans here, John Suffields here, and their AI buddy who will help grab all those questions and put them into the YouTube chat, and then I will randomly grab those questions, not randomly, of my choosing, and answer them. The show is 2 hours long. So again, you're contractually obligated to stick around for 2 hours. Once you begin, by clicking like, you have agreed to stick around for the entire 2 hours. So I give emphasis to the people who've never had a question answered before. So if you're feeling like you got a question that's burning a hole in your brain and you thought, well, Fraser will never answer it. Actually, I'll try to answer those questions. But then if I run out of those, I'll definitely answer the questions of the people who've asked questions before. Keep in mind that I am a journalist, not a scientist. So I cannot provide you additional information above and beyond what is the scientific consensus. But I promise the scientific consensus is all we need. And third, we get a lot of questions, a lot of over and over and over and over again. And so I try to spread things out a bit. So hopefully I won't answer the same question week after week after week. And so if I don't answer your question, it's probably because I either don't know the answer and I'm just sneaking around it, or I feel like I've answered that question too many times. And you're going to have to decide. Don't take it personally. Just say, oh, of course, this question that I have, Fraser's answered this so many times. I understand when he didn't answer. Not that he doesn't know the answer. All right, let's get started. At this point, I'm assuming a bunch of questions have been pulled in. There's a second version of my colors. Interferometry and Lagrange. Music cassette. Does Earth have Trojans? In other words, are there asteroids at the Earth, Sun, L4, and L5? Yes, the Earth has Trojan asteroids at its L4 and L5 Lagrange points. So for those of you who don't know what a Lagrange point is, these are places that are, okay, let me see. When you have two masses and one mass is 25 times or more compared to the other mass, so in other words, the sun compared to the earth compared to the moon, then you get 5 places where a test particle, in other words, something with 0 mass, will experience a balance of gravity. And so it won't drift in any specific direction away from this location. That is the sort of the textbook version of the Lagrange points. And there are 5 of these spots for every 2 body interaction. So there's the 3 that are lined up between, say, the sun and the earth, one on the far side of the sun, one between us and the sun, one on the far side of the earth, and then there are 2 ahead and behind of the earth in its orbit. And those ones ahead and behind, those are the L4 points. While the ones that are lined up, they are gravitationally unstable. The ones that are ahead and behind the earth, or Jupiter, or whatever, they are gravitationally stable. In other words, that if you drop your test mass, this particle, into this region, it will remain orbiting around inside this region. And so what that does is that tends to collect debris, garbage, asteroids, comets, spacecraft, and so on. That if you moved into this Lagrange region, then you can, at a slow enough velocity, and if you go into some kind of 3-body interaction or some further gravitational perturbation from Jupiter or whatever, then you can be trapped inside of this region and you just start orbiting around inside of it, while at the same time, this whole region is orbiting around the sun in front of the Earth and behind the Earth, or in front of Jupiter or behind Jupiter. And so astronomers call this garbage, asteroids. Should I call asteroids garbage? Sure, why not? Call this stuff the Trojan regions. And so Jupiter has its L4, L5 Trojan points. And one sort of big surprise is that the combined mass of all of the objects in the Jupiter's Trojan belt matches the amount that's in the main belt of the asteroid belt. So there's a lot of stuff that gets caught in these regions. And this is where NASA's Lucy mission is going. It's going to be visiting one of the Trojan belts and then come back and then go visit the other Trojan belt. But there are Trojan regions around every single planet. There are Trojan asteroids have been found around Mars in its L4, L5 point. They've been found at Saturn. They've definitely been found at Earth, and maybe they've even been found at Venus. I don't think they've been found at Mercury. Maybe they haven't been found at Venus, actually. They've been found from Earth outward. But the size of the object that can remain in the Trojan area gets smaller depending on the mass of the secondary object. In other words, Jupiter is very massive. And so Jupiter can have very large Trojan objects. They can be hundreds of kilometers across. Earth is much smaller. Earth has much less mass. And so the size of the objects that get trapped in Earth's Trojan belt are significantly smaller. They are in the order of tens of meters. They're definitely, kilometer at the most, I think. They're definitely not hundreds of kilometers the way they are with Jupiter. But are there asteroids at our Trojan belts? Absolutely. Pura Vida Hoser. All right, hold on. Pura Vida Hoser. Do neutrinos move faster than light as we know it? Okay, you got to explain your username here to me. So Pura Vida, that is what they say in like Costa Rica, isn't it? To like chill out, but at the same time, hoser, that's a Canadian saying. So are you a Canadian living in Costa Rica surfing? You have to explain this to me. Anyway. No, neutrinos do not move faster than the speed of light. They move a little bit slower than the speed of light. And neutrinos, these are particles that are produced in nuclear reactions. They're streaming out of the sun. You have countless neutrinos passing through your body at all times. And that's because they don't interact with regular matter. It's always been said, a neutrino can pass through a light year of lead unaffected. And so, yeah, you've got neutrinos streaming through you right now. They go right through the Earth and so on. But they do this slower than the speed of light. And there was a controversial discovery about a decade ago where some researchers thought that they had detected neutrinos moving faster than the speed of light. And they had sort of set up an emitter in one location. They'd set up a detector in another location, and they'd measured how long it took for the signals to go from, or how long it took for the neutrinos to go from the source to the detector. And they calculated that it was going faster than the speed of light. And this was a huge announcement and discovery, and it broke the laws of physics as we understood it. And it turns out there was a loose cable in their system that was measuring the travel time. And once they, screwed it back in, then the neutrino travel time behaved properly, which is that it's a little bit slower than the speed of light, but not a lot. We always talk about this idea of supernova going off, that the first thing that we see after a supernova goes off are the neutrinos. And it's not because the neutrinos are going faster than the speed of light. It's the neutrinos it's not that the neutrinos are going faster than the speed of light. It's that the neutrinos can get out of the star faster than the radiation does, because the radiation piles up inside. The radiation piles up inside. It's stopped by all of the particles of the sun, the radiation piles up inside. It's stopped by all of the particles of the star, while the neutrinos, as I said, they pass right through matter. And so they get a head start on the light escaping from the supernova. And then we see the neutrino flash, and then within a couple of hours, like 3 hours, then the light shows up. The reality is the light was traveling faster this whole time, and it had to catch up to the neutrino burst. That's for like Betelgeuse, if the distances are farther, then the gap grows. But no, neutrinos do not move faster than the speed of light. Ha! I nailed your username. Okay, awesome. Paul Davis, update on the killer. Paul Davis, update on the city killer asteroid, please. So we have been reporting on this asteroid 2024 YR4 for a couple of weeks now on the channel and on Universe Today. And when it was first discovered, the first initial rudimentary measurements of this asteroid was that it had about 1% chance to strike the Earth in 2032. And then follow-on observations were made, and astronomers upped that percentage to 2.3%. And I think most recently I've heard that the number is up to 2.6%. So still, that is below 3%. Still, that is a 97+% chance that the asteroid is going to miss us in 2032. But it's definitely something we want to keep an eye on. Now, there have been previous asteroids that have threatened to hit the Earth at some time in the future, and sort of the scariest one of these was asteroid Apophis, which was going to hit the Earth in the mid-2030s. But then follow-on observations of Apophis brought down that percentage chance it was going to hit until it was 0. And that is because calculating the trajectory of an asteroid is very difficult, that you have to make multiple observations of the asteroid over multiple nights. Sometimes you get clouds. You want to use it from multiple instruments at multiple locations on Earth. And over time, you build up this very accurate understanding of the future trajectory of the asteroid. Keep in mind, like, you're trying to measure what this asteroid is going to do 8 years into the future based on just this snapshot of its movement. And of course, there's going to be all of these gravitational interactions from the Earth, from the Moon, from Jupiter. All of these are going to play a part in its future orbital trajectory. And so astronomers run the math, and this is what they got up with. And, you know, as asteroids go, this isn't anywhere as scary as Apophis was. Apophis is big. This asteroid is probably in the 40 to 100 meter range. When you think about the Chelyabinsk meteor, that was probably in the 20 meter range, and it caused this airburst and blew out all the windows in a large area. People were injured, but nobody really died. This is going to be more like Tunguska, which hit in 1908, and was like a bomb going off, like a several megaton nuclear bomb being let off in a Siberian forest. It blew down trees in a huge area, and probably very few people died. We actually kind of don't know who was there because it was so long ago. But if this thing hits a city, then it is like somebody dropping a nuclear weapon on a city. It's a bad day. And so we definitely want to try and understand it. Now, the trajectory has been calculated that if it does hit the Earth, it will probably hit somewhere along the Atlantic Ocean, Africa, into Australia. So you can imagine this straight line, which is where Earth will be when this crossing happens. So it's a 3 on the Torino scale. Astronomers measure this danger scale from 0 to 10, and 3 is a regional devastation with a very low likelihood of hitting. And we're going to wait. But my expectation, the thing that has happened every single time, there's probably been 10 plus asteroids that have gotten onto the Torino scale, and then they all get off again, which is that follow-on observations do a really good job of calculating where they are, and then it reduces to 0. And as asteroids go, this one is eminently dealable, processable, handleable. As asteroids go, this is one that we can deal with. We saw what happened with the DART mission when it crashed into asteroid Dimorphos. It caused a significant change to the orbital period of this moon orbiting around its main asteroid. And this object is kind of in the same class as Dimorphos. And so if people work together very quickly and get a mission off the ground, they can have an impactor crash into this asteroid within a couple of years, and then that would be enough of a kick. And then that would be enough of a kick to make sure that it doesn't hit us down the road. But if you've seen the movie Don't Look Up, you know how this could go, where people put it off, they don't really accept the risks, and then it gets too late. And then maybe we have to risk the chance of a, the equivalent of a nuclear weapon going off somewhere randomly on the surface of the Earth. JB Grooves, does the astronomical community track the Space Force space shuttle? Sort of. So what you're talking about is the X-37B, and this is a space plane that was originally developed by the Air Force, is now handled by Space Force. And every couple of years, the Space Force launches the X-37 into low Earth orbit. It spends a year plus, 2 years in orbit around the Earth, and then it re-enters the atmosphere, lands, and then whatever purpose it had has now been complete. And, we don't know exactly what the X-37B does. It's classified, but when you think about what you could do in that kind of a mission, it sort of constrains your possibilities, which is, and also NASA has had experiments on the X-37B, and they've talked about those experiments. And so you get a sense of like what NASA is doing is probably what Space Force is doing. They are testing electronics in space. They are deploying different instruments to find out how well they work. They're trying out different kinds of materials, exposing them to the vacuum of space for a long period of time to find out how well they behave. And so you can imagine, if Space Force is going to develop new camera systems, new materials, new things like that for their upcoming super scary secret spy satellites, they're going to want to make sure these things work in space. And this is the way that they can launch these things to space, try them out for a couple of months in space, and then bring them back to Earth and see how they did. But can you track the position of the X-37B? And the answer is absolutely. It's really hard to hide an object in low Earth orbit. Now, NORAD, the U.S. Space Force, and other groups are tracking all of the various objects in space, and they do classify the positions of a lot of their objects. And so they're not in the public databases, but there are other databases that you can find some of these things. But then there are private companies. Leo Labs is a good example, and they are tracking the location and position of pieces of space junk that are a few centimeters across. And so they can absolutely track the position of something like the X-37B. And you can imagine that various other nations, the Chinese, the Russians, others, totally know what is the current position of the X-37. In fact, we've seen examples where the Chinese version of the X-37 or other satellites or ones done by Russia have changed their orbits. And so it's possible that various nations are working on satellites that can do things. They can loiter, they can catch up to and try to observe more closely other satellites from other nations. But, once you launch these things into orbit, they're relatively easy to catch. Like, I'm sure you can go outside. If you know where to look, you can watch the X-37B fly overhead with your own eyes. One who studies 1 miles square foundation on Mars. Your thoughts? I don't understand the question. A foundation, like a concrete foundation? Oren Adrianov. Hey, Fraser, what is the ultimate destiny of stars? Will a white dwarf just burn out one day and go poof, disappearing into nothing? So when a star, I'm not going to talk about supernova and they turn into black holes or they turn into neutron stars. Those have their own future destinies. Black holes evaporate. But you asked about a white dwarf, so let's go down that pathway. So a white dwarf is what you get when a star like our sun dies. It uses up all the fuel in its core. It's turning hydrogen into helium, turns helium into carbon, and then at a certain point, it can no longer maintain the pressure and temperature in its core to keep doing fusion to go up to heavier elements. And so it bloats up as a red giant, puffs out its outer layers, and then what's left is the core of the star that has now been revealed to space. And it is about half the mass of what the sun was. So if you had, a star like our sun, or the sun, when the sun turns into a white dwarf, it'll be about half the mass of the sun. And it is now a white dwarf. And it starts out at the center of the sun, the temperature is 15 million Kelvin. So it is very hot. And when the sun goes through this process, bloats out its outer layers, and then it's exposed to space, it cools down to about 150,000 Kelvin. And this is the sort of what a white dwarf is. And then it's going to slowly cool down because it no longer has fusion. And as it cools down, it starts to crystallize. So, it had turned all of the helium into carbon at the center of this star. And you get this blob of very hot carbon, and then slowly it cools down, it cools down, it cools down. After about 1 trillion years, it freezes solid and turns into a diamond, this giant space diamond. But that's not the end of the white dwarf, because you're still potentially getting you're still getting particles that are forming at the center of this white dwarf. And you're getting these matter-antimatter pairs that are sort of building up at the center of the white dwarf. And after, it's a 10 to the power of 1100. So like a ludicrous amount of time. If a googol is 1 to the power of 100, after about that, 10 to the power of 1100, the white dwarf detonates in this sort of puff of matter and antimatter, and it's gone. So yes, they burn out, and then a ludicrous amount of time later, they probably explode. 10 to the power of 100, not 1 to the power of 100. 10 to the power of 100. Ian, would we have colonized Mars by now if it had air? That is a great question. Man, that is such a good question, because, when we think about Mars today, it is the worst, right? It has a very thin atmosphere made of carbon dioxide. It's pretty bad. It has 1/3 the gravity that we experience here on Earth. It doesn't have a magnetic field to protect it from radiation. There's a lot of problems with Mars. But what if it did have an atmosphere? So then you would have a place, it would probably still be cold. Like maybe Mars was a place like that 4 billion years ago, where it was warm enough and the atmosphere was thick enough that you had lakes and rivers and things like that. Now, it would probably still be carbon dioxide. There's no reason why it would become a breathable nitrogen, oxygen atmosphere like what we have. And so then you've got an analogy of a place that is like that, which is Antarctica. Antarctica is cold, and doesn't have a lot of plants and animals and things to live on, but it does have air, and you can breathe the air. And yet we have not colonized Antarctica. And getting to Mars and trying to set up on Mars and live there is dramatically more difficult because the distances involved. So even if Mars was like Antarctica, I don't think we would have anything more than a research station on Mars. If it was like the most habitable place it could possibly be, it's still too awful for us to want to colonize it for any long term. And so I love that perspective that you're like, well, okay, like what if it wasn't so bad? Would we want to colonize it then? And I don't think we would. I think we would have a research station on Mars sooner than when we eventually will. But I still don't think that we're going to have, people aren't going to want to live there for very long. And all you have to look at is how many people live in Antarctica, which is just the people in the research stations. But I love that as a way to kind of set your expectations, right? What if you made Mars like Antarctica? Would we colonize it? We don't colonize Antarctica, and it's farther, so no. Like I think it's really important for us to and like this is something you gotta like sit down and chat with your therapist about, I think, which is like, why do you want to live on Mars? Like what is it? What are you hoping to get out of this? And I think that your opinion, your take on this is influenced by science fiction that, when they go to Mars in the studio, they're not on Mars. They're on Earth. They're breathing. It's the same gravity. They're experiencing normal amounts of radiation. They've got a crafts table they can go over and stuff their faces when they get hungry. All of these things don't exist on Mars. That we have this pioneering spirit at our hearts that we want to watch episodes of Alone or Survivor and watch people struggling in difficult circumstances and feel like that is what brings out the best of humanity. But there's plenty of places on Earth that are vastly more habitable that you can go out and you're on your own and carve out a lifestyle living in tune with nature, and yet you're not doing that. So what is it about Mars? You're going to Mars because you want to help get Earth's eggs into multiple baskets? Well, there's lots of ways that we can help improve the resiliency and the future safety of humanity here on Earth. And I would argue that, in fact, we're not doing that in many cases, right? So, yeah. That is like the most brilliant question I think I've had in weeks. I love it. Thank you. Aidan Weatherby, if you were an astronomer entering their PhD in astronomy in the area of exoplanet science, what would you do for a research project? So, I mean, this is where the reality that I'm a journalist and not a scientist has to take over, which is that anytime I have a question or think of something, it turns out people are already researching that. So, although I cast this very wide net across lots of ideas and I'm exposed to lots of stuff, I'm not so deep in one specific field that I know what are the outstanding questions that need to be answered. Are you asking, are you an astronomer entering your PhD in astronomy in the area of exoplanetary science? Or you're just wondering if I was going to do research, what would I come up with? And you can see this, like I'll ask a question to an astronomer in one of my interviews, and they'll give me an answer. I'm like, oh, okay, of course somebody's thought of that. Dougal, you mentioned D&D before. What other hobbies do you have? Let's see. I get too many hobbies. So what are my hobbies? Playing video games, playing role-playing games. Although, both of those, I don't have as much time for them as I once did. I am restoring this old piece of logging land that we live on here in Canada. And so that means I'm going out with a chainsaw. I'm cutting out invasive species. I am running a wood chipper and planting native trees. And I'm building a food forest where you have apple, and this isn't out in the sort of the wider forest. We have more of an orchard. And I am planting tons and tons of fruit trees and berries and ground plants and things like that. My dream is to be able to like walk out and just eat fruit from the trees around me. So I'd say that's pretty big. Somehow my wife and I became birders. It sort of like snuck up accidentally. And so we run the Cornell birding app on our phones, and we'll go outside and we'll hear birds. And we live in the middle of the forest. And so, on a good day, we'll get upwards of 20, 30 different birds showing up on the bird app in like an hour. I mountain bike. Where I grew up on Vancouver Island, where I live, mountain biking is huge, and everybody's got fancy mountain bikes. They spent more than, they cost more than a person's car. I have an older sort of hardtail with I've got a softtail now. Yeah, I've got a dual suspension mountain bike that I ride. I hike. I do overnight hikes here on Vancouver Island. So I've got a lot of pretty cool ultralight hiking gear. So gardening, hiking, I'm learning Mandarin Chinese, which I don't know, is that a hobby? I don't know. I watch a lot of science fiction. I watch a lot of movies and television shows with my wife. I cook. I pretty much cook all the food that we eat here in the house. My wife doesn't cook. She's getting better. But she's vegan, and if you've seen Pulp Fiction, that means that I'm vegan too. And so I cook a lot of vegan food. Travel. So I like to travel, although, we didn't get a chance to travel much since COVID, but in the last year, actually, I took my son to Japan and I took my other kid to Amsterdam and Iceland. And my hope is to try and get out to one trip a year. My wife and I are sort of planning where we might go next. Any other hobbies? I think that's it. I think those are my hobbies. I guess astronomy. Looking through the telescope. Real quick, English plus Mandarin gives you access to half of the language speakers. That's exactly it. That's the reason why I wanted to learn it, was that, there's like 1.4 billion people that speak this language that I don't understand. It's a culture that I just have no connection with and no insight into. And now I do. Not that I speak. How about growing hair? Oh. Mad Monkey Oz, what is the impact on the Canadian Space Agency due to the goings-on with your southern neighbors? We have no idea right now. So Jared Isaacman hasn't been brought on board, hasn't been officially confirmed as the NASA administrator yet. Although, when you see the other nominations that have flown through the Senate, I can't imagine that he won't have a problem getting confirmed by the Senate. Or I can imagine he will have a problem getting confirmed by the Senate. And then we don't know. And it's funny because, we've been seeing a lot of cuts to NASA. You're seeing a lot of changes to the website. You're seeing a lot of sort of contractors. People are being laid off, shut down. A lot of grants are being frozen. And so that's having an impact across a lot of stuff, but we haven't seen the big ones happen yet, right? We haven't heard of a cancellation of the Space Launch System. We haven't heard of a change from going to the moon to going to Mars, that kind of thing. Canada's involvement. We built one of the instruments for the James Webb Space Telescope. We supply the robotic arms for the various space shuttles and for the International Space Station. We'll probably be providing the arm for the upcoming Lunar Gateway. There's a lunar rover that has been developed by Canada. And I think sort of like and then we have a handful of astronauts that are active in the astronaut corps. And sort of one of the big prominent missions for a Canadian coming up is Artemis 2. This is where they're going to do this flyby around the moon. And so there's a Canadian astronaut that is going to be on that flight if it happens. So right now, like there's been like just so much news that's been breaking about the impact of the new administration on science in general, about the various new regulations, the kinds of work stoppages that have been happening, the changes to the amount of overhead expenses that people are able to charge for. Like, it's been across the board. But we haven't seen much so far that we've needed to report on for space exploration specifically. Nothing's really gotten cut. So maybe we're gonna wait for Jared Isaacman to come in, and then he'll start implementing the various changes that are in the works, or maybe it's just gonna be steady as she goes. They're just gonna keep going with whatever were the plans beforehand. It's very hard to stop spacecraft. They're mid construction. So but so right now we haven't heard any impact in how it's going to affect the Canadian Space Agency yet. But as soon as, like, I'm waiting for various impacts to happen, and then we're going to report the hell out of them. Just looking at the questions. Cusick, why do people keep saying that black holes have immense density? The bigger the black hole, the smaller its density, for example. So black holes can be measured by two numbers, which is the mass of the black hole and the spin of the black hole. Now, you can also calculate the charge of the black hole, but let's just deal with the spin and the mass. So when you have the mass of the black hole, that gives you the size of its event horizon. And then the mass, the size of the event horizon, and then you can calculate the density. And it's a relatively easy calculation to make. And so different size black hole event horizons are going to have different densities. And the event horizon is purely just that spot where the escape velocity exceeds the speed of light. If you are able to go the speed of light and no faster, because obviously that's the speed limit of the universe, that defines it. And so you can just go and take any black hole that you want. You take its volume in, cubic meters, and you divide it by the mass, and that gives you the density. And so even though the densities can be, in some cases, lower, strangely lower than what you might be expecting, still, that is the implications of having that much mass compacted into that much of a space. But I would stop there. God's Garbage and Fraser, have you heard about the company who just got a NASA grant to manufacture blown glass living structures on Mars? Yes. Yes, I have heard that. Didn't I break that news? Hey, Fraser, did you hear about that interview that you did? Yes. Yes, I did. But let's put the link in the show notes in case you missed it. Whoops. There you go. There's the link. Jordy B. Hello from Sapporo, Japan. Are there any potential new targets for New Horizons? So New Horizons spacecraft, this is NASA's mission to visit Pluto and give us close-up images of Pluto for the first time. And it made the flyby of Pluto, man, like what, 2015? Like almost a decade ago? That's crazy. And then it moved on out into the Kuiper Belt, and astronomers did a large survey of the region, and they were able to find a couple of objects that were within its flight cone of what it had enough propellant to be able to get to. And so then it did a second flyby of an object called Arakoth and gave us really cool new images. The thing has this sort of double-lobed blobby structure that looks like two separate Kuiper Belt objects kissed. But it still has fuel in the tank and is still within communication distance of Earth. And so theoretically, if another object is found within its future light path, light cone, it could try to reach, give it called a light cone, flight cone. If another object is found within the region that it can get to, then they will absolutely task it to do another flyby and multiple flybys, however much fuel it has. I've talked to Alan Stern. He's the principal investigator of New Horizons, and he is just adamant that this is something that they'll be able to do into the future. The trick is they have to find the target. And there are not a lot of survey instruments that are capable of detecting Kuiper Belt objects that are that faint, that dim, that far away from the Earth. But there is a new telescope that's coming later this year, which is the Vera Rubin Observatory. And, we've talked about this ad nauseum, but Vera Rubin, because of the way it works, it's able to see objects that are incredibly dim. It's surveying the region that New Horizons is going to be flying into, and theoretically, it should be able to find the kinds of objects that New Horizons could fly to next. And once it does, then you know that they're going to task New Horizons to go and visit one or multiple of these until it finally runs out of propellant and it can no longer reach a new target. But yeah, its spacecraft is doing fine. It still has work to do. I can't wait for it to see another object. Yeah, 2015 was like last year, I swear. Yeah. Multi-fan, how often do people call you frasercain? Less and less every year. I was talking to a young woman. Oh, she was a cleaner in our house, and I said, okay, so what's your name? And it's frasercain. And she goes, okay. I'm like, like the guy from Cheers, the guy from that show. And she's like, looked at me blankly, like, what show? I'm like, yes. I had the name first, Kelsey. Give it back. Joseph Apples, what do you think about the IC's proposal for a lunar sling on the moon? I haven't seen that. Ravi come up. When will we explore caves on the moon and Mars? I feel those areas of exploration are unfulfilled. So I've done plenty of interviews about caves or lava tubes. So let me give you a... Yeah, here we go. So this is an interview with somebody who has been consulting for the European Space Agency for exploring lava tubes on the moon and Mars. And I ask a question like that. There you go, Darth X. Who's Kelsey? Exactly. Who is Kelsey? I don't know who Kelsey is. James Sobek. Do gravity waves reflect... Let me do this again. Do gravitational waves reflect from masses that they wash over, the way that water waves reflect from islands or shorelines? So gravitational waves, these are caused by mass that is moving through the universe. That as you are walking around, when you're driving your car, you are releasing gravitational waves into the universe. Some amount of your just kinetic energy is turning into these gravitational waves that are then emanating out. Now, we can only really see the most massive versions of these when black holes are spiraling in the last few seconds. They let out these gravitational waves that are detectable by the kinds of experiments that we have here on Earth. But what happens to gravitational waves as they move past various masses like planets, stars, even black holes? And, when we think about regular waves, when waves pass islands, they can reflect, they can bounce off, they can be distorted. And so does the same thing happen to gravitational waves? And the answer is yes. When you have a gravitational wave that moves through space-time, it is affected by space-time in the same way that when a photon moves through space-time and it gets too close to a gravitational well, then the photon will be deflected. It thinks it's following a straight path, but the reality is that because you've got this mass that is distorting space-time, then the photon will follow this what it thinks is straight space-time, but in fact is a curved path from our perspective. And so gravitational waves, as they move through distortions in space-time, they will also follow the paths that are most appropriate for them. And so you can imagine you've got gravitational waves that are moving towards, say, a black hole, which is sort of like the ultimate version of this. You can imagine gravitational waves that are moving towards a black hole, and this is sort of like the ultimate version of this question. And as the gravitational waves get very close to the black hole is torquing around space-time, then the gravitational waves are going to get deflected and distorted and go around this black hole and have their directions changed and so on. But the black holes that cross the event horizon go in, and they actually add to the mass of the black hole. And so, it's not very much, and when you think about the amount of kinetic energy that is contained within a gravitational wave, very little is going to turn into appreciable mass in the black hole, but it's not zero. And so when a gravitational wave gets close to a black hole, it gets distorted and can have its directions changed, concentrated, all kinds of things. And any that falls right into the event horizon becomes part of the black hole. I'm not older than Kelsey Grammer. I have just had the name Fraser Cain longer than the character on Cheers had the name Fraser Crane. Does that, do the math? I was born in 1971. Cheers started in 1982? So I had the name for 10 years before some idiot randomly came up with a name that has now haunted my dreams. Clockwork Rex. When do you think we'll see Betelgeuse explode? We have no idea when Betelgeuse is going to explode. The problem with stars like this is they don't tell us how much of their mass they have consumed at the core. When Betelgeuse is going to explode really is due to when it runs out of fuel in the core. Right now it is fusing together various elements. It's moving farther and farther up the chain of elements, and eventually it'll reach iron. And when it reaches iron, you can't get any energy out of fusing iron beyond what you put into it. And so there will be no longer this light pressure that's coming out of the core, and then that causes all of the light pressure that's holding the star against the pull of gravity to implode, and then the thing will detonate as a supernova. And how long will it take for Betelgeuse to explode? It could be tomorrow, and it could be 1,000,000 years from now. And Betelgeuse is 640 light years away from us, and so that means that it could have exploded 640 years ago, and then we will just see the light tomorrow and know that it already happened. There's like a 1 in 7,000 chance that it has already exploded, but most likely it will not happen within our lifetimes. It'll happen within the next few 100,000 years. But what if we did see Betelgeuse explode? It'd be incredible. It would start to brighten up over the course of about 10 days to reach its maximum brightness, and it would become as bright as the moon. Not necessarily as bright as the full moon, probably brighter than a quarter moon, somewhere in between that. But it would be very bright, like you could navigate outside. But it would be coming from a point object, not this circle, not from the moon, which would be very strange. You could see it during the day. And then it would slowly dim down till about, say, 3 months later. It would no longer be visible during the day, only visible at night, and then it would slowly fade away, and then you just wouldn't be able to see it again because now it would be dead. Rob Wright, could an Earth mass planet exist stably at the barycenter of two stars of similar mass orbiting each other? In a way, the two stars would be orbiting the planet. All right. In a way, the two stars would be orbiting the planet. So theoretically, yes. You can imagine that when you have two stars that are exactly the same mass, down to the atom, and they are orbiting each other in perfect circular orbit, then they are orbiting around a barycenter. They're orbiting around a center spot. And if there's no other stars in the universe, no other galaxies, nothing around them, then they will continue on this perfect mathematical precision forever, right to the end of time. And then at that very barycenter, you put a planet in the middle of it, and that planet was positioned to within a quadrillionth of a meter, I don't know the amount, an infinitely small amount, and it was perfectly circular, had no mountains, no distortions, nothing. It was just this perfect sphere down to the trillionth of a nanometer, sitting in the middle of the barycenter. Then you would have a stable system where the two stars are orbiting around, and this planet is sitting in the middle, and everything is perfect forever. But reality is that the stars aren't going to be the exact same mass down to the atom, that the planet is going to have a wobbly gravitational field with different mountains and densities of material inside of it, and that the stars are going to be on not a perfect circular orbit. They're going to be on slightly elliptical orbits. And then the planet is going to start to sort of move around inside this area. And eventually the instabilities are going to grow. And then the planet is going to join one of the stars. So that's what the reality is going to happen. And it won't take very long. If a few decades, hundreds of years, the planet will be destroyed. Potato Biden, how much dark matter is in our solar system? About an asteroid's worth. A small asteroid. quelque part français ici et pourrait m'aider à traduire une question. But I don't know what I just said. Horizon, Phoenix Warp Brave. Do you fear that Musk will try to fold all of NASA into SpaceX? So, All right. So, like, do I fear that? No. What I fear is the administration making changes to NASA without the approval of Congress as what is required by law. And Congress being unwilling to stand up for their own job, being the people who create the laws in the United States, and the Supreme Court failing to enforce the law. So like that's that's what I'm nervous about. And if that series of event happens, then it's all cuckoo banana land, right? Like then the administration can do whatever they want. They can shut down NASA. They can give all the parts to SpaceX. They can do whatever they want. So there is the law in the United States, which defines the budget that's given to NASA, that defines the kinds of goals and work that NASA is supposed to do. The Artemis mission, the Space Launch System, these are all in the law. The various missions that are upcoming, these are all part of the law that Congress sat and voted, and they put out a budget and defined that this was going to happen. And what we're seeing is an administration that is testing whether or not laws matter in the United States. And it's quite peculiar. It's quite bizarre to watch this happen because, my understanding is that you're supposed to follow laws. And that's a thing that the United States is quite fond of. They have the Constitution. They have these documents. They've set out very clearly how this is supposed to work. And you're watching this potentially not work. So there's kind of two paths. One path, and I'm just going to disregard it because I can't wrap my mind around it. And that is that Elon Musk and the administration, they just decide what happens. They take apart NASA. Laws don't matter. Who cares? We're living in a topsy-turvy world. So, and then if that happens, then the dissolution of NASA is like the least of the concerns that anyone is going to have, right? Like there's all kinds of other problems where laws are no longer being followed, where, you have to be concerned about that. So then you've if laws are followed, so the way you can imagine things happening with NASA is that Congress, is going to come up with with recommendations from the current administration, from Elon Musk, from other people. They're going to come up with a new set of laws that define what NASA is going to do. And so you can imagine them on the more extreme side dissolving NASA, right? Like just shutting it down. They're going well, you've got SpaceX. So I don't think you can imagine them folding NASA into SpaceX. You can imagine them just dissolving NASA. And then any future space exploration that is required by the U.S. government is just done through private contractors, be it Blue Origin, be it SpaceX, be it Firefly Aerospace, all that kind of stuff, right? You just privatize space exploration entirely, but you still set aside budget. And we see a hybrid version of that right now. Like right now, when you get on, when NASA wants to send astronauts to the International Space Station, they pay for a commercial flight on a SpaceX Crew Dragon, and they pay $60 million per seat, and they don't have to worry about building the rocket and maintaining the rocket and all of that kind of stuff. So there are places where it makes total sense to pay for a commercial provider to deliver the results of the of what you're looking for. And my guess is there's like a whole bunch of the stuff that NASA does today that could theoretically be privatized, outsourced, whatever, right? But then there's like a whole other part that NASA does that no commercial company would want to do, and that is research. That is taking risks on the kinds of things that no existing company, corporation, research group can afford to do. Testing out new kinds of propellant systems, new construction methods, determining how safe it is for us to go to space. There are thousands of really interesting research projects that are done every year by NASA where nobody is asking themselves, does this make money? They're asking themselves, can we learn how to do this? Does this tell us something about the nature of the universe? Does this tell us something about how to live and work in space? Does this tell us something about the nature of our planet, about our atmosphere, about all this kind of stuff? Basic scientific research. And it is, for some of it, if there is money to be made in pharmaceuticals and various kinds of health therapies and things like that, you can imagine you can privatize that. Like companies, giant pharmaceutical manufacturers will do research to figure out ways to produce new kinds of medicine. But there's a whole range of scientific discovery that's just not done, right? What is the return on investment for studying supernova? What is the return on investment? There isn't. But at the same time, as a society, we want to be able to do scientific progress. And so if you privatize NASA, I can imagine a version where they privatize NASA or shut it down, but then they set up a completely separate, very functional, very streamlined research organization that's only job is to research interesting and important new technologies, to push human knowledge forward, to help lay the groundwork for us to be able to become a true spacefaring civilization. And that all sounds really exciting. So as long as that happens, then I think someone could very carefully with a scalpel reduce the some of the projects that NASA is working on and it not end up being a disaster. But it doesn't feel like that's the direction that it's going right now. If you're seeing what's happening across various other parts of the of the government, of the bureaucracy, it's very much a machete. And so I'm assuming that when it becomes NASA's turn, then it will be the same kind of thing. And, it's, when you have people who are researching something very complicated, they've got funds, they're expecting, there's hardware they're depending on, and you just shut all that down, then they have to go look for a new job. And then the whole research just ends. So, do I fear that Musk will try to fold all of NASA into SpaceX? No, I don't think so. What I fear is them doing a clumsy job of attempting to shut down NASA. But I'm not an American, so I don't have a vote. I have opinions about how Canada funds science research, and it's really good. I like it. York, Fraser, I was wondering what you think about fusion propulsion and what the timeline for such systems could be, considering private companies laying ambitious goals for the decade. So I've got a interview that I did about a fusion propulsion system as part of NIAC, and unfortunately, the audio was unusable. And so I've sent a brand new microphone to the person that I was interviewing, and we will conduct the interview again. And so then we'll find out. And so I remember the conversation, and we actually posted a story that was the transcript of my conversation on Universe Today about this propulsion system. It's pretty cool. Essentially, there's two main flavors of the way fusion works right now. You have the the low density version, the tokamak reactors, where you've got this torus where you've got hydrogen that's at very high temperature, and you try to have fusion happen inside this. And then you have the high density things like the National Ignition Facility, where they've got like a little capsule of deuterium, and they shoot it with 192 lasers, and they raise it up to 100 million Kelvin and get out more energy than they want. But what they're called helical fusion, and they're proposing a sort of middle ground, that there's a whole range of density scenarios and temperature scenarios where you might be able to get fusion going without it being sort of one extreme or the other. And so NASA is funding with an NIAC grant for them to explore this sort of medium density fusion propulsion systems. And so, space, if you can get a fusion reaction going, space is great because you don't have to worry about all of the radioactive particles that are coming from like a fusion reactor generates a lot of radioactive particles. And so you don't have to worry so much about that when you're out in space, as long as you're far enough away from, or it's a spacecraft, right? It's a robot and doesn't care. So I'm going to redo the interview in a couple of days, and then we will post that probably in another couple of weeks. So stay tuned for that final NIAC interview coming up. Okay. Pat Logan, are there rogue gravitational waves? Yeah, I mean, theoretically, there would be rogue gravitational waves. That two gravitational waves that overlap with each other can combine their strength and align their troughs and align their peaks in the same way that water waves can. Man, it sucks losing the audio for an interview. It is like, because you have to it's like the first time it's like this genuine exploration into this topic. And then the second time you're just trying to remember the rough path that you followed and try to trigger the conversation a second time. Ugh. I don't like it. You need more space stuff in your background. Are you kidding me? I guess it's time to play. I gotta oil this again. What's in the background? What's in the cabinet? So this, next up, last time we looked at dust from Mount St. Helens, and this is a nickel iron meteorite. Specifically, this is from the Campos del Cielo meteorite strike that happened about 4,000 years ago in Argentina. And I got to cover my eyes or else the camera will focus on my eyes. So hopefully that works. And it exploded over this huge area in Argentina, and people to this day are still finding meteorites, digging down on the ground and finding meteorites. And this is a pretty heavy, this is about a pound. And it is this beautiful chunk of space metal that my wife gave me for my birthday one year. And I really love it. Although it's starting to get a little rusty. So I have to oil it. You have to sort of WD-40 this thing. But then I also have... So that's the big one. But then I also have, I have to leave the camera. Can I do this? Okay, don't. So these are little chunks of meteorites from the same asteroid strike. And you can buy these on eBay. And they're not that expensive. So if you're looking for, if you're looking for a cool gift for somebody, go onto eBay, look for the Campos del Cielo meteorite, because those are like the cheap ones, because there's a million of them. And you can get ones that are this big. And so often when I go and visit new people, I give them a meteorite. And I tell them that it gives them a superpower. There you go. Space things. All right, fine. Well, here's another one. Space things. So this, there you go. Cover my eyes. Perfect. So this is protomolecule. So this comes from the Expanse TV show. And this is an actual set that they used on the Expanse to have protomolecules. So I've got a couple of pieces of the protomolecule. And so somebody who worked on the Expanse gave these to me. And then also I've got some slugs that came from the Expanse. So if you remember when they were on that world in the Expanse near the end of the show, they had these little slugs that showed up, and that's all they were. I've got a couple of the slugs. I promise you, everything that's behind me is space related. So, yes. We have space stuff. Chad, I apologize. I don't think that got grabbed as a question. I'll see if the guys grab it later on. Do you have a shop to sell stuff from your website? Nope. Dawson Reddick, any thoughts on the February 6th supernova detection event? Not really. So what this was essentially a detection of a gravitational wave at the same time that the Ice Cube Observatory detected a flash of neutrinos. And so if confirmed, this is probably the most important gravitational wave detection ever, maybe after the Kilonova event, because now you get this independent measurement of the speed of neutrinos. And from that, you can measure all kinds of other things. And it hasn't been announced in this very comprehensive way. There's been some science papers that have come out so far about this, but we haven't sort of seen, or there's been sort of notifications of the various events, both the gravitational wave event and the neutrino event, but I haven't seen anybody put this together into an actual paper yet. So I'm kind of waiting for a paper that I can then hang a conversation off of. But Ethan Siegel over at Starts With a Bang had a terrific article about sort of what it is and why it's so important. Interesting if true. And I know that Anton Petrov did a video a couple of days ago. I assume he based it on Ethan Siegel's article. Let me see if I can I'll get you the article. So it's a week ago. All right. So that's the article. Wait, Fraser's Canadian? Yes, I'm Canadian. It's hilarious when people will, in this sort of really nasty tone in my YouTube comments, be like, you Americans, blah, blah, blah. And then I get to say, I'm not American. John Seffel, have you heard about the perfect Einstein ring around NGC 6505? Allow me to point you at the most recent episode of Space Bites, where we talk about the Einstein ring. It's this one, right? Yeah. I can do this all day. Yeah, Anton is Russian Canadian. Like, he lived in Canada, and now I think he lives in like Korea. Okay. Fraser, can I borrow your passport? You just have to marry me. It's too late. I already married an American. Ooh, that's a great question. Web Fiji, which will have a greater devastation on Earth if it strikes? A solar system comet, an interstellar comet, or an intergalactic comet? So comets hitting the Earth are bad. But what causes the damage of a comet hitting the Earth? And comets are actually a little scarier than asteroids hitting Earth for a couple of reasons. One is they come out of nowhere. So with an asteroid, as we see with 2024 YR4, we get years of notice that this asteroid is on this potential collision course, and we can figure out a way to try and change its trajectory years in advance so that it doesn't hit us. With a comet, they are coming out of nowhere. Often they're coming for the first time down into the inner solar system from the Oort cloud. And so you have at best months of warning, a year of warning before the comet is going to hit your planet. But also, comets can fragment. And this happens a lot. We see a lot of comets as they get too close to the sun, they can fragment and break apart. And so you can have a situation where a comet could go around the sun, come back towards us, and then fragment. And then the fragment would create a larger area that could then impact the Earth. And if you had a comet that was tens of kilometers across, but it fragmented into chunks that were a couple of kilometers across, and they would just pepper the Earth more like a shotgun. So that's scary. But that's sort of like half of the problem with comets, and the other half is the speed. So comets are coming down, falling into the inner solar system, and they can be falling very quickly. They can be coming faster than an asteroid can hit the Earth. But the farther away the comet came from, then the faster it's probably going. Because, like, for example, Oumuamua, when it was coming through the solar system, it's on a hyperbolic orbit. It is traveling so quickly through the solar system that it's not being trapped by the gravitational well. It's falling in, and it's falling, and then it's going back out to then continue exploring the Milky Way. And so it's going faster than the kind of comet if it just started out in the Oort cloud and fell in. Now, an intergalactic comet, I mean, if let's say we have comets here, the Earth, and they have to escape the Milky Way, then they have to be going 550 kilometers per second to be able to escape the gravity of the Milky Way. And so if you've got some comet that's in some other galaxy and something kicks that comet out into an intergalactic velocity, it could be going 1,000 kilometers a second, right? Like way faster than anything we could see coming through the solar system. And if one of those hit the Earth, well, then you've got a lot more damage. So of the three choices that you gave me, the intergalactic comet would be the most worrisome. But of course, you have to consider the mass. It's all about the mass. So a small mass moving quickly is the same damage as a large mass moving slowly. And so really, what is the mass? But I would be more worried about an intergalactic comet. And when you think about it, we've seen intergalactic stars that are passing out. Well, I guess, hypervelocity stars that are on their way out of the Milky Way because they had this close interaction with the supermassive black hole at the heart of the Milky Way, that there are almost certainly hypervelocity stars that are coming from other galaxies moving into our galaxy, and probably they're bringing with them comets. And so this is entirely possible, but the number of them actually happening is going to be very low. Daniel Pazar, would it be possible to grow a plant on Mars using only soil and water, as in The Martian? With poo. All right, that's good. Hey, Fraser, would it be possible to grow a plant on Mars using only poo, soil, and water, as in The Martian? Theoretically, yes. Could you take a plant, an earth plant, and could you take poo and mix it with the regolith and then mix it with water and then grow plants in it? So theoretically, yes. Now, there's a couple of problems you have to deal with. The first thing is that there's this stuff called perchlorates, which are in the first few centimeters of Martian regolith. And this is the light from the sun is breaking up molecules on the surface of Mars, and it's creating this sort of chlorine that's in the upper part of the regolith. So you would have to wash the regolith to get rid of the perchlorates. It's another step. It's not impossible, but it's something you have to remember. Otherwise, it's poison. It's toxic. It's toxic to people. It's toxic to plants. You don't want your plant growing in that. So you wash your regolith. You've got your fertilizer. You're mixing that all together, and then you're making, little pots where you're trying to grow plants in it. Will the plants grow? And the answer is yes. In fact, people have done, nobody has actually gotten their hands on enough samples of Mars to try the experiment of actually growing stuff in Martian regolith, but people have created simulated Martian regolith, which we assume is very close to the kinds of meteorites that have come from Earth, and plants grow just fine in the beginning, as long as they have access to the nutrients. As long as they have access to the bacteria that helps to mediate the nutrients coming into their roots, then the plants can grow. Now, will they grow in lower gravity? Probably. That's probably not a big issue. A recent Chinese rover had an experiment on board where they germinated plants on the surface of the moon with lunar regolith and proved that yes, the plants can grow briefly, and then it went into the lunar night and they all froze to death and died. But theoretically, that would all be fine. Now, there's a couple of other challenges though, and this is one that people don't really think too much about, and that is that the radiation that falls onto the surface of Mars is significantly higher than it is on Earth. You're experiencing at least 100 times as much cosmic radiation and solar radiation on the surface of Mars, or like you're experiencing solar particles, charged particles coming from the sun, and you're experiencing cosmic rays. And it's believed that those are too hostile to plants for them to be able to grow. And so if you wanted to build your Martian style greenhouse where you've got glass roof and you've got sunlight pouring through, but also you've got cosmic rays that are pouring through, the one paper that I saw said that it's not sustainable, that the plant can't handle the amount of radiation that it's experiencing and be able to grow and thrive. So chances are you're going to have to grow this underground. So you're going to have some kind of tunnel where you've got lighting, LED lighting that you are using to, grow lights that you're using to light your the area where you're growing your plants, and you've got hydroponics probably where you're running water to everything. Then yeah, theoretically you can do it. And in fact, the European Space Agency has a garden, has a greenhouse in Antarctica at Concordia Station, and they grow tomatoes and strawberries and all kinds of fresh greens and stuff in this fully enclosed environment in Antarctica. They're able to keep it warm enough. They've got grow lights inside the building that's able to provide enough illumination for everything to grow. And they are testing out, they're essentially trying to learn, what does it take for us to grow plants in an environment where we can't access sunlight, where we can't keep things, it's not warm enough outside, but there's still air, which is still an advantage. Although Mars has carbon dioxide, which plants crave. So there would be a lot of challenges. As long as you're willing to grow your plants underground, it should be possible. Argillon soil is different from regolith. I forget how though. Yeah, well, regolith is just crushed up rock. And soil contains crushed up rock, but also organic material and bacteria. And it's the bacteria that you need because plants put down their roots and then bacteria cluster around the roots of the plant and deliver nutrients to the plant through this network. And so if there is no organic material in the regolith, in the soil, then there's no way, there's no bacteria, and there's no way for the plant to derive the nutrients that it needs out of the soil. So you need to have organic material. If you can, and that's what the poo is for, is you get the organic material mixed in with the regolith and you can grow things. Electrolytes are what plants crave. Yeah, not carbon dioxide. Bob Smith. They created a computer program to look back at James Webb data and found new asteroids. Could they use that program to look back at Hubble data? Not only can they do. And so there have been plenty of science papers that have come out over the years where researchers have gone through all of the Hubble data, all of the pictures taken by Hubble ever, and searched for asteroids and turned up thousands of asteroids, brand new, never before discovered asteroids. So this is done all the time. And actually, I like these kinds of stories, this kind of research where someone takes the leftovers of someone else's research and uses that to find other things. So I'll give you an example. The Chandra X-ray Observatory, is used to look at very specific targets, and then it has to turn to a new target and then do more imaging at the new target and then slew to a new target. Well, someone took all of the slewing data. They just let Chandra keep its detectors going while it was moving to new targets, and they were able to find new discoveries in all of the times when Chandra was just moving to new targets. So there's a lot of really cool experiments. And one that's really great recently is, there are all these giant radio telescopes that are gathering data on pulsars and the center of the Milky Way and things like that. And folks from the SETI Institute have built a computer program that takes a copy of a pipeline of all of the radio data that's being gathered by all of these giant science experiments, and then they're searching through this radio data for any evidence of signals from extraterrestrial civilizations. And so it's allowed them to have this enormous volume of radio data to dig through and find the needles in the haystack. So there's lots of examples. Scientists are very resourceful, and when they see that there's just something there that they can use, often they'll come up with a clever way to be able to use it. Fraser, can you change the name of Uranus, please? Like to George's star? Liminal, Fraser, do you think that AIs could become religious? Uh, There's a great book by Ray Kurzweil called "The Age of Spiritual Machines," where he proposes that over time AI will become spiritual, and I feel like he predicted 2029 30 years ago, and we're getting pretty close. Like Ray Kurzweil's predictions on the capability of artificial intelligence in the future is stunningly accurate. I highly recommend you go back and read The Age of Spiritual Machines. He doesn't really address the alignment problem, the control problem, all of the kind of big issues that safety researchers are coming up with about artificial intelligence, but it's kind of amazing how well he predicted it. Gary died. Do you think if Venus had air, we would colonize it? So Venus is really interesting. Like Venus is the same size as the Earth, roughly. It's the same mass, and it's made of the same stuff. Also, Venus has double the nitrogen that Earth has in its atmosphere. Like Earth's atmosphere is 78% nitrogen and 21% oxygen. And the atmosphere of Venus, even though it is 99% carbon dioxide, it's so thick, there's so much atmosphere that it still has twice the amount of nitrogen in its atmosphere that Earth does. And so you could take that oxygen, break the carbon dioxide, you got your oxygen, you got the nitrogen. You could, if you could go and just like chip away at all those atoms, you could build an Earth atmosphere at Venus out of the raw material. The thing you're missing is the water. That Venus is bone dry. It doesn't have the hydrogen. Hydrogen was long lost. Either it got sucked into the planet or it escaped out into space because of the solar wind. And so you wouldn't get oceans and rivers and so on, but you could have a Earth-like atmosphere. But at the same time, like Earth's atmospheric oxygen was produced by plants, by cyanobacteria. And so the cyanobacteria couldn't live on Venus. So it wouldn't last for long. But let's say that for some reason, the atmosphere or the conditions on Venus were very much more like Earth, that you had Earth gravity, Earth mass, Earth size, roughly the same kinds of chemicals that we require, Earth density of atmosphere, that you had a temperature that was reasonable, maybe a little warmer, but not a ton warmer. You didn't have a runaway greenhouse effect. Would we colonize Venus? So it's back to that same question, which is like, are there places on Earth that are reasonable temperature? They have the same, they have the gravity that you're used to in New York City or wherever you're from. And yet you don't colonize them. Right? So it's hard to go to Venus. And so I think even if Venus was perfect for life, but like didn't have plants, didn't have animals, was just a barren area, but yet you could walk around on it and breathe and not die, we wouldn't do more than a research station for a very long period of time, because it's still very far away, very hard to get to, very expensive to do. The gravity in New York City is unpleasant. Is it high gravity? Mark McGinnis, is it possible that some of the galaxies that we see are composed of antimatter? Wouldn't they look the same? Yeah, in theory, if we could see a galaxy and it was made of antimatter and all of the stars were made of antimatter and all of the planets were made of antimatter and everything was antimatter and there was no matter in that galaxy, it would look the same. But the problem is that we know that our galaxy is made of regular matter, and that if a galaxy made of matter collided with a galaxy made of antimatter, then you would get annihilation. You get a release of gamma radiation. It would be very obvious. And in fact, when we see bright spots we can detect the gamma radiation coming from the annihilation of antimatter in various places around the universe. And so if there was entire galaxies made of antimatter, there would be this border between the ones that were made of antimatter and the places in the universe that were made of matter. And there is the intergalactic medium where you've got particles of hydrogen that are moving through space. There's rocks and dust. There's hypervelocity stars that are moving from galaxy to galaxy. And there would be these places where the two parts are mixing and exploding. And it would be the most obvious thing in the universe. There'd be parts of the sky where antimatter and matter annihilation was going on at a scale we can scarcely comprehend. And it would just be super obvious. And we don't see that. What we see, as far as we can look in all directions, is regular matter hanging out without interacting with antimatter. but it'd be cool. Just looking at the questions. So many. J Blob. Fraser, could you maybe explain what the function of NASA is? Because a lot of people seem to think NASA makes rockets and they've always used contract companies to make rockets for them, etc. I went into a pretty big, long NASA rant, so maybe we'll save something like that for a future week. Are we on to page 2? Holy moly. I need to speed this up. So many questions. This is awesome. Adam, have you watched the excellent animated show Pantheon? I was the first to recommend Scavenger's Reign to you. Yeah, Adam, first, thank you for recommending Scavenger's Reign. I showed it. My wife and I watched Scavenger's Reign. My son watched Scavenger's Reign. It is the most interesting space-related sci-fi show that I've watched in the last year. It was phenomenal. Yeah, I've seen Pantheon. It's recently came out on Netflix, and so we watched that, and it's really good. So if you're looking for a good, kind of scary show about artificial intelligence, there's sort of a couple of very disturbing scenes in it, but it's really good. So definitely recommend it. Let's see. Wow. I didn't realize there were so many questions. TJ, do you think we'll see humans on Mars in your lifetime? I mean, I'm going to live through multiple robot bodies until the end of time. So yes. But let's say that I don't move into a robot body, then will I see a human on Mars in my lifetime? Yeah, I'm 53 now. And it's 2025. So let's assume that we see humans on Mars by 2045, 20 years from now. So I'll be in my early 70s, which, my dad is 80. So I like my chances. Diddly D, I wonder if Fraser would like to play Starfield. Seems like it'd be up his alley. I've sort of seen enough about Starfield that it's kind of not up my alley. Like, I like space games. I play a ton of space games. I really like No Man's Sky, but Starfield just kind of looks tedious. But I really liked Outer Wilds. That was good. So Aaron Roberts asking about what's happening with NASA. I did a conversation about that earlier. Tom Tooney, Fraser, have you ever had an alien join the chat? How would I know? Steve Wolfbrat, Steve Wolfbrat, are we witnessing the slow disclosure of ETs? I don't think so. we're seeing a bunch of people who've been making kind of the same claims for a long time continue to make the exact same claims, but nobody is actually producing the kind of evidence that scientists could sink their teeth into and do any further research. You're getting allegations that there are classified programs at NASA, you're getting allegations that there are classified programs in the U.S. government, that there are people who know about what's really going on, that there are hardware from aliens that have been recovered, that there are bodies of aliens that have been recovered, and yet none of this stuff is ever revealed. And so you're getting more interest, but no further evidence. And NASA put together a committee to do investigation. The Air Force put together a committee to do an investigation. Like, you notice, like, none of it went anywhere. So, there are things that people observe and they don't have an explanation for it, and that we may never get an explanation for it. But it doesn't mean that there isn't a natural explanation for what that thing is. It's just that we don't know which of the things it is. Is it a balloon? Is it a drone? Is it Venus? Is it a plane? We don't know what it is. And because there just isn't enough information to be able to positively identify what it is. But, but nobody so far has ever provided evidence that people can look at that is not within the realm of what we do and what we can do. That every time someone provides sufficient evidence on something, it turns out it was something that we already knew, like a balloon or a drone or an airplane or whatever. So no, I think, and it's funny because I'm surprised that people are still getting ever more excited by this. And like, at some point, I know you're going to get exhausted. You're going to get too frustrated and get impatient and like, when is this going to happen already? And it all seems like the same. It's never going to happen. That nothing that is being shown so far is worth getting really invested into. There's an interesting paper that came out today, and we're going to report on it in Universe Today, and I'm probably going to talk about it in Space Bites in an upcoming couple of weeks. And that is that somebody put together a paper on what it would actually take to search for UAPs, right? To search for UFOs. And that would be space-based monitoring, ground monitoring. You'd be looking for seismic events. You'd be monitoring the water. You'd be listening to sonar. You would have ground-based telescopes that are observing. You're looking for thermal signatures. You're looking for radar. You're trying to scan planet Earth at a level that, if there is the kind of thing that people are seeing that seems to violate the laws of physics, then we would catch these things. And so, but this kind of a research program is going to cost tens of millions, hundreds of millions, billions of dollars. And so the question is just, is that the best way to spend billions of dollars? Some people would say, yeah, absolutely. Let's protect ourselves from the alien incursion. And other people would say, let's cure diseases. Let's learn more about the cosmos. So we'll find out how far this goes. But I like, mark my words. And like, people say, like, are you going to eat a big slice of humble pie, right? I would love nothing more than for us to find evidence of aliens in the universe, that we are not alone in the universe. That would be the most fundamental, most profound discovery that humanity could possibly make. It would be amazing. But my feeling, watching how this has played out over decades, is that it's going to continue to be a nothing burger. That it is not disclosure. That you will not find out anything interesting. There will nothing be tangible. People will continue to make allegations, and no evidence will be provided. While at the same time, you're going to have these space telescopes like the Habitable Worlds Observatory. You're going to have these missions that are going to Mars, missions that are going to Europa, that are going to be looking under the ice. They're practically looking for evidence of life on other worlds. And those are going to be the ones that deliver the goods first. That the first evidence that we find that we are not alone in the universe will come not from a UFO, but will come from a space telescope. So that's my bet. And that for the people who are excited about UFOs, you're going to wait and wait. And it's going to be really frustrating and it will never deliver. While space telescopes, they have a much better chance of delivering. Cassie Ream. Wait, I thought you said that we were alone. I get this all the time, which is like, what's your personal opinion? My personal opinion is that the Fermi paradox is so profound and it tells us that we are alone in the universe. And that's my personal opinion, right? But I don't think that my personal opinion should influence the search for life in the universe. That we should, like, you don't just follow your gut about this kind of thing, you check. And so I would, like, the first thing that we should do, or the thing we should continue to do, is to search the solar system, listen for signals of extraterrestrial civilizations, build more and more powerful telescopes that are capable of scanning the atmospheres of other planets, searching for evidence, technosignatures, things like that. We should push on all fronts to figure out whether or not we are alone in the universe. And that we can never know if we are truly alone. We can just fail to find evidence at a larger and larger scale. And so I find the Fermi paradox quite troubling. I mean, not even troubling. I find it, the universe is big and old. Life should be everywhere. We don't see it. Where is it? One plausible explanation is that we're alone. The one that seems most likely to me, philosophically. Place your bets. That's where I would place my bets. But it is not a scientific conclusion. It is purely the feels. It's the vibe. So you're saying there's a chance. Mad Ash, not science related, but since it was just Valentine's Day, how'd you meet your spouse? Online dating, like, how does anybody meet their spouse? But the hilarious part is that our anniversary is Valentine's Day. So not our wedding anniversary, but like the day that we first met was 11 years ago on Valentine's Day. And so we consider that to be our actual anniversary and not our actual wedding anniversary. MySpace. What movies would be in the Fraser? Oh, good question, actually. I'm going to rant for 5 minutes, for 6 minutes. 8 kids on the horizon? No, I've already got 2 kids. They're done. Mad Monkey Oz. What movies would be in the Fraserverse? So I think a lot about this. And that is that I am exhausted by the existing way that science fiction movies are done. Like, you pretty much just get them coming out of Disney. You get Star Wars movies, you get Marvel movies, okay, you get DC movies, and you get Star Trek movies. And then you get some science fiction movies that have nothing to do with all of those. But really, what's happening with Disney is like this black hole that is vacuuming up. I know that's a bad analogy because black holes don't suck things in. But anyway, it is a whirlpool, a vortex of gobbling up movie budget, and that is because the movie companies are cowards and they want to go with established intellectual property and try to turn those things into movies that have the best chance of returning their money, and they're not willing to take risks on really interesting and exciting story ideas. But there are so many incredible stories that have been told in science fiction books that are just waiting. Like Dune is the tip of the sandberg here. The Expanse is a good example of a really well told science fiction series that was just ready and ripe to be turned into a television show, and they did a phenomenal job of turning it. And now The Expanse is one of the best television shows, best science fiction shows ever made. And so I'm sure people who are watching this, you can think of the kinds of movies that could be made from some of the best science fiction stories that have ever been told for decades, all the way back to the 1960s. A lot of those stories still hold up. Foundation is a good example, but you could turn these into television shows. And so if I could, some of you are going to cancel me today and you're never going to come back. And I understand that. And I'm sorry, this is how I feel. But I would not make any more superhero movies, except for Invincible, which isn't a movie, it's a television show. But anyway, I would not make any more Star Wars movies. I would not make any more Star Trek shows. And I like Strange New Worlds. It's fine. It's a good show. But anyway, I would take that budget, the billions and billions of dollars, and I would invest it in turning wonderful science fiction books into incredible movies across tons of different genres. So, yeah, I'm so sick of superheroes, so sick, and I'm sick of Star Wars, except for Andor. Andor can stay, but the rest of it can get lost and be replaced with money spent on turning incredible, innovative, creative science fiction stories into other media, television and movies. That's what I want. I know I'm not going to get that, but yeah, there we are. All right, the Culture series. Yeah, the Revelation Space series would be amazing. There's so many good books, so many good stories that have been told, and they're just sitting there. We got The Martian. The Martian is the perfect. Didn't you love The Martian? Where did that come from? It came from Andy Weir, who was a computer programmer, and he wrote this book and he released it online, and then later on he turned it into a book, and then it got picked up as a movie, and it was phenomenal. And another Andy Weir movie is coming out with Project Hail Mary, and hopefully that's still going to be good. But even that, you're dipping into the well twice, the Andy Weir well twice. And I'm not a giant fan of that. I'd rather they spread the money around and they go and talk to different authors. When are we going to see an Ursula K. Le Guin story? When are we going to see some more Isaac Asimov stuff? When are we going to see some more Ray Bradbury stuff? When are we going to see some Paul Anderson, Larry Niven, Jerry Pournelle? God, there's so many great authors for decades and decades and decades. And now you're getting this fragmentation of media where people don't share. You get Dune. Okay, fine. Dune, they did a great job. They made a great, version of Dune. And then you got the Prophecy of Doom. Well, now it's starting to turn into a new, you're going to have, was it like Dune Emperor? You're going to have the Children of Dune. You're going to have Lil Dune, right? You're going to have animated Dune, rogue Dune soldiers. Anyway, so that's what I want. Heinlein. Yes. Ben Bova. Werner Vinge. Can you imagine a Werner Vinge? That would be yeah, that would be so great. Yes, please. Okay. Dune on Ice. Dune 2 Electric Boogaloo. Dune Twinsies. Yeah. See, there you go. Enough. We got it. We got a Dune movie. Okay, fine. Maybe. No, I don't even want to see the rest of the Dune movies. I'm done. Just stop take that budget, take that incredible director, that incredible Canadian director, and have him go to his library and pick a new book out that he likes and have him make that movie. All right, Dune of the Dead. All right, thanks everybody. We've reached the end of our 2 hours. A huge thank you, as always, to the moderators. Give a shout out to Zapfan and John Suffield for helping pull all of those questions and put them into the database, so I'm able to answer as many questions as humanly possible. Next week is going to be the Australian edition, which means that it's going to be at 10 p.m. Pacific Standard Time, which is going to be 1 a.m. Eastern Time, but it's going to be 5 p.m. in Sydney on Monday. So I'll put the event into the calendar and keep an eye on that. All right. Thanks, everyone. And we will see you next week or sooner.